Hello everyone, welcome to our first lesson for General Chemistry 1. In this video, we'll talk about math. This includes classification of matter, states of matter, and separation techniques. Matter is classified into two, mixtures and pure substances. But before we deal with the classification of matter, let us first define what matter is. Matter is anything that occupies space and has mass. When we say it occupies space, it must have a volume. We have here the naturally occurring states of matter. These are solid, liquid, and gas. We have here water as an example. Water occurs in three different states: in solid, in liquid, and in gas form. If we look at the water molecule in ice, we can see that they are constricted and formed in a more rigid structure. While in liquid state, water molecules are still close together but they can move around freely. While in gaseous form or in steam, water molecules are moving freely and randomly. They are far apart from each other compared to the other two. Now let's talk about phase change. Melting is the process where solid turns into its liquid state. You can observe that when you heat up ice or when it's very hot, ice melts and turns into liquid or simply water. And that is what you call melting. But when you place liquid water in an extreme low temperature, then it will freeze and turn into its solid state. And that is freezing. The next process is evaporation. Evaporation is the process where liquid turns into its gaseous form. You can observe it in boiling water. You will see that there is a steam formation when water boils. But when you cover up that container, you will observe that droplets of water will be formed in the cover. And that is the process of condensation. So that happens when water vapor or steam lower down its temperature and it will go back to its original state, which is in liquid state. The last two processes are deposition and sublimation. Deposition occurs when there is a rapid decrease of temperature or rapid drop of temperature such that steam will directly solidify without going to the process of condensation. Meanwhile, sublimation is the process where a solid form of matter directly vaporizes. So when you heat up ice spontaneously, it will sublime or it will vaporize without going through the process of melting and evaporation. Most matter around us comprise of mixtures of different pure substances. The main characteristic of mixture is that it has a variable composition. Let's take these as examples. Wood is a mixture of different substances. Wood of Nara tree may be different from wood of acacia tree. They have different composition, so they are mixtures. Even brass in your doorknob is a mixture. It is composed of two metals which are copper and zinc. And the last example is the ocean water. It is a mixture of water and different minerals. Mixtures are classified into two, homogeneous and heterogeneous mixtures. Homogeneous mixtures has visibly indistinguishable parts. Let us take these figures as examples. You can see that the figure on the left shows that salt is being dissolved in water. Based on our previous knowledge, if you mix salt in water, it will be dissolved and it will form a clear mixture. So you cannot distinguish salt with water. But when you mix oil and water, you can distinguish two components or two parts, which are the layer of oil and layer of water. Heterogeneous mixtures are classified into two. These two are colloids and suspension. In colloids, particles of one substance is dispersed throughout a dispersing medium made of another substance. So you can see that the figure above shows that the orange particles are dispersed in a dispersing medium. You can also see the comparison between a solution and a colloid. Take note that a solution is also called a homogeneous mixture. Looking at this figure, the difference between solution and colloid is the particle size. Colloidal particles are larger compared to the particles dissolved in a solution, while in suspensions, particles are sufficiently large for sedimentation, hence will settle on the bottom upon standing. You can see above a blood sample. When you leave a blood sample overnight, you will observe that the red blood cells will settle on the bottom since red blood cells are heavier compared to the other components in blood. This is something for you to take note. In order to know the difference between a solution, colloid, and suspension, you must know that their only difference is in particle size. If the particle size of your solute is less than 10 raised to negative 7 cm, then it will form a solution. But when you dissolve a solute having particle size between 10 raised to negative 7 and 10 raised to negative 5 cm in a solvent, it will form a colloidal mixture. But when the particle size dissolved is greater than 10 raised to negative 5 cm, then it will form a suspension. Now that we know the first classification of matter, which is mixture, let us now proceed on discussing pure substances. When you say pure substances, it is one with constant composition. Let us take these as examples of pure substances. 100% ethanol. It is different from the ethanol that you have as a rubbing alcohol. 100% ethanol is different from your rubbing alcohol. Rubbing alcohols contain 70% ethanol, others have 70% isopropyl alcohol, but as you can see, it is not pure. It has a ratio of 70-30. 70% of ethanol is added with 30% water. But on this one, 100% ethanol is present. Another example is a Swiss fine gold. It has a purity of 99.9%, which means that it is pure gold. And the last example is butane fuel inside a tank, and it is composed of purely butane. There is no other present substance in the material. Pure substances are divided into elements and compounds. Elements are substances that cannot be decomposed into simpler substances by chemical or physical means. Let's take gold in the previous slide as an example. Even if you divide or even if you purify that gold, you will end up having an atom of gold. So, it is an element. Meanwhile, compound are substances with constant composition that can be broken down into elements by chemical processes. Let's take 100% ethanol as an example. It is considered as a compound. Ethanol is made up of elements hydrogen, carbon, and oxygen. And when it undergo a chemical process, it can be broken down into its elemental forms. Okay, that's it. You can now see the summary on how to classify matter. Does it have a constant composition? If yes, then it is a pure substance. If it contains various type of atoms, then it is a compound. But if it's not, if there's only a distinct type of atom, then it is an element. If matter does not have a constant composition, then it is a mixture. If there is no visibly distinguishable parts, then it is a homogeneous mixture, or simply a solution. If there are visibly distinguishable parts, then it is a heterogeneous mixture. Now, it will now depend on the particle size if it is a colloid or suspension. Or simply, you can just wait and let the particle set to the bottom if it is a suspension. If it did not settle, then it is a colloid. Let us proceed on the separation techniques. These are only the most common separation techniques that you might need on your lessons in General Chemistry 1 or the things that might only appear in entrance exams. The first separation technique that we'll talk about is evaporation. It is a technique used to separate out homogeneous mixtures or solutions where there is one or more dissolved salts. This method allows the separation of the liquid component of a solution from its solid component. This process typically involves heating the mixture until it is completely dry. The next process is distillation. Distillation is a process that depends on differences in the volatility of the components. That is, how readily substances become gases. In simple distillation, a mixture is heated in a device such as the figure shown. The most volatile component vaporizes at the lowest temperature, and the vapor passes through a cold tube or a condenser where it condenses back into its liquid state. The most volatile component vaporizes at the lowest temperature. So we'll go back to our discussion and phase change. When you heat up a liquid, it will vaporize or it will proceed into its gaseous state. Now, once that vapor passes through a cooled tube or a condenser, that vapor condenses back into its liquid state. The simple one-stage distillation apparatus is shown below. Another method of separation is simple filtration. This is used when a mixture consists of a liquid and a solid. The mixture is then poured into a mesh, such as a filter paper, which passes the liquid and leaves the solid behind. You call those solids as residue and the filtered solution as filtrate. The next method of separation is chromatography. Chromatography is the general name applied to a series of methods that use a system with two phases or states of matter, a mobile phase and a stationary phase. The stationary phase is a solid, such as in this example is the filter paper, and the mobile phase is either a liquid or a gas. And in this example, it is in liquid form, which is acetone. The separation process occurs because the components of the mixture have different affinities for the two phases and thus move through the system at different rates. You can see here in the example, the carotenoids moved faster compared to the other components. And you can also see that there are other components separated, which then are illustrated as these different smears of colors. This is an example of a paper chromatography. It uses a strip of porous paper such as filter paper for the stationary phase. A drop of mixture to be separated is placed on the bottom of the paper, which is then dipped into a liquid, the mobile phase, in this case the acetone, that travels up the paper as if it is a wick. This method of separating mixture is often used by biochemists who study the chemistry of living systems. For our last example for separation techniques, we have here centrifugation. It is a technique used for the separation of particles from a solution, according to their size, shape, density, viscosity of the medium, and rotor speed. The particles are suspended in a liquid medium and placed in a centrifuge tube. The tube is then placed in a rotor and spun at a defined speed. If we'll go back to our example of suspension, it was said that if we leave a blood sample overnight, red blood cells will settle down. In order to fasten that process, we can use a centrifuge. Okay, so before we end our discussion, let us have practice exercises. Matter is classified as a mixture or a pure substance, which is not an example of a mixture. A. Dust particles scattered in the air. B. Oil and water in a beaker. C. 70% ethyl alcohol. Or D. Sulfuric acid. The correct answer is letter D. Sulfuric acid. All of them are having variable components except sulfuric acid. Question number 2. The active volcano on the left shows the release of gaseous sulfur. After cooling down, sulfur gas turns into its yellow solid form. Which phase change below occurred? A. Condensation. B. Deposition. C. Precipitation. Or D. Sublimation. The correct answer is B. It is deposition because the process is from gas to solid. Question number 3. You are interested in identifying the amount of methanol present in your alcoholic drink, knowing that it is toxic when consumed at a large amount. Which of the following techniques should be used? A. Centrifugation. B. Chromatography. C. Distillation. Or D. Evaporation. The correct answer is letter C, distillation, because your alcoholic drink is a mixture of different substances with different volatilities. methanol is very volatile such that it will vaporize first than the other components of your alcoholic drink. For our fourth question, your professor gave you a beaker containing a mixture of salt, water, isopropyl alcohol, and sand. Your task is to place each component into four separate containers. Which separation techniques should be used to accomplish this task? 1. Centrifugation. 2. Chromatography. 3. Distillation. 4. Evaporation. 5. Filtration. The choices are A. 1 and 3, B. 2, 4, and 5, C. 3 and 4, or D. 3, 4, and 5. The correct answer is letter C. If your answer is letter D, then you might be tricked by this question. Since your task is to place each component into four separate containers, you cannot use evaporation as a separation technique because it will remove all the liquid components of the mixture. Hence, you cannot place water and isopropyl alcohol in their container. So the correct answer is C. 3 and 4 are distillation and filtration. If you are still confused by the correct answer, then let me explain. So the first thing that you should do is filter sand from the mixture. After that, place the filtrate into a distillation setup. Then you let isopropyl alcohol be separated from water and salt. Once all isopropyl alcohol is removed in the mixture, then you let water vaporize such that it leaves a dried solid substance in your distillation setup, and that is now your salt. For our last question, ice is less dense than liquid water because A. Solid molecules of water have less mass. B. Molecules in the solid phase of water are not in motion. C. Molecules in the solid phase have less kinetic energy than in liquid phase. Or D. Molecules in the solid phase of water have more space between them than in its liquid phase. The correct answer is letter D. If your answer is not letter D, then take a look back on the image of water molecules in ice and water molecules in liquid water.